Imagine zipping across the galaxy, not in centuries, but in just a few years. Sounds like science fiction, right? Scientists are now talking about building engines so advanced, they could rewrite the laws of physics. Could NASA create a real-life warp drive? Let's find out. Earth won't be home forever. Whether it's climate change, asteroid threats, or human curiosity, one day we'll need to head to the stars. But here's the cosmic buzzkill: space is ridiculously huge. Our nearest star system, Alpha Centauri, it's over 4 light-years away. And even if we somehow manage to fly at 100 times the speed of light, which, spoiler, we can't yet, it would still take over 4 years to get there. Traditional rockets, forget it. They guzzle fuel and are too slow for interstellar travel. Space doesn't have gas stations. Enter the EM drive. No exhaust, no fuel tanks, no problem. Microwaves bounce around and create thrust. It looks like a coffee can, and it defies physics. You see, Newton told us that to move something, you've got to push against something. Rockets push against their own exhaust. Planes push against air. You jump by pushing off the ground. But the EM drive, it pushes against nothing. That's why it's so controversial. Some scientists claim it produces a tiny bit of thrust, like barely move a piece of paper tiny, while others say it's just measurement error. Could this be the engine of the future, or just a very expensive science fair project? Now let's talk about engines that are working, starting with the Ion Drive. Ion propulsion sounds straight out of Star Wars, but it's very real. Instead of burning fuel, it shoots ions, which are charged particles using electricity. The result? Incredibly efficient thrust. NASA already used it on the Dawn spacecraft, which explored asteroids between Mars and Jupiter. And now they're investing big in more powerful versions, perfect for deep space missions. Sure, ion drives are slow to start, but over time they build up serious speed. Like the tortoise in space, slow and steady wins the race. If you really want to go fast though, nuclear power is where things get wild. One idea? Nuclear pulse propulsion. Basically, you set off mini nukes behind your spaceship to push it forward. It's like riding an atomic pogo stick through space. Sounds crazy, and it kind of is, but it's theoretically super powerful. NASA and other space agencies are now experimenting with more realistic nuclear solutions. The upcoming Zeus spacecraft from Russia, for example, will use a mini nuclear reactor to hop between the Moon, Venus, and Jupiter by 2030. And the US? They're eyeing nuclear power for future moon bases with test launches as soon as 2027. But who needs fuel when you've got the sun? In 2019, SpaceX launched LightSail 2, a spacecraft powered by sunlight. No engines, just giant reflective sails that catch solar radiation and turn it into momentum. It's slow, but it works. In fact, solar sails could be perfect for long-haul cargo missions across the solar system. But we're not done yet. Let's talk about the holy grail of space travel. Warp drive, yep, the thing from Star Trek. Scientists used to say it was impossible because it required exotic negative energy that doesn't exist, at least not that we know of. But now, a group from the Advanced Propulsion Laboratory says they've built a new model for a physical warp drive, using real physics. Instead of moving through space, a warp drive would bend space itself, expanding it behind the ship and compressing it in front. The ship sits in a bubble and never actually breaks the speed of light. Space itself just moves. Wild, right? Even better, this new version uses way less exotic energy than before. It's still theoretical, and we're decades, maybe centuries, away, but it's no longer impossible. Even the guy who created the first warp drive theory, Miguel Alcubierre, gave it a thumbs up. We're not quite at warp speed yet, but from ion drives and nuclear thrusters to solar sails and EM drives that challenge physics itself, the future of space travel is looking more real and more exciting than ever before. Will we crack warp drive in our lifetime, or are we just dreamers looking up at the stars? Let me know in the comments below. And if you love science, space, and the future, like, subscribe and ring that bell so you don't miss what's next. Until then, keep looking up.